What's up, everybody? I am not a software engineer, but I did manage to make my own heat map for stock symbols that I'm interested in. And so I'm actually on the GitHub repo for what I've called heat map. And you can actually see a screenshot of what that might look like. And of course, this is based on stock information for popular symbols from the S&P 500, and that includes stuff like Home Depot, Netflix, Apple, so on and so forth. Now, in the event that you have your own stock portfolio and you are interested in creating your own heat map, then that is something that we will accomplish today in this tutorial. So basically what I've done is, in typical fashion with GitHub repos, is I've just gone ahead and cloned this heat map locally. And so I'm going to bring up a terminal window, and you'll actually see that here. So I can do an ls, and you'll see all the files that exist within here. So one of the first things that you'll notice is that I actually do have a .go file, and so I am using Golang here. And I can do something simple, such as go run git portfolio.go. And if I do this, it's going to try and kick off some logic that we will discuss in just a moment. But if I did just want to have basically, I guess, a depiction of this mixed day, which is a little bit green, a little bit red, and a little bit neutral, I can basically just type in anything, but really just command line arguments of what we're looking for. So I can do data, and that will serve this to a local host web server that I can then open like this, and so you can actually see what that looks like. Now, this is obviously simulated data and not based on any specific day, but if I did want to simulate a green day, I could go ahead and type in green, and then we could obviously go right back to localhost, and then I'll refresh there, and you see a green day. And then finally, we'll test a red day, and then I'll refresh and you'll see red. So that actually is a nice little demo. If you wanted to do that yourself, that is how easy it is. Of course, you will need to have Go installed on your system in order to make this work. But yeah, so I wanted to kind of show you what it would look like if you wanted to create your own portfolio. So in VS Code, I have this open, and really the interesting part is myport.csv, because this is where you would input the stock symbols that you have in your portfolio. And so again, these are just symbols taken from the S&P 500, and I basically put a random number right here in order to kind of have I guess a demonstration of how many shares exist in the portfolio. And of course, that would give us the weight distribution for how large these squares should be in the heat map. And if you're unfamiliar with this concept, I did actually have basically where I stole the idea from, and that is FinViz, right? So these heat maps here basically happen every single day when the stock market is open. So this was kind of a neutral day. As you can see, we have some green, some red, and some neutral. Neutral being kind of this purple color here, and then red being down, and green being stocks that went up. And then you kind of have these varying degrees of those colors. So that's basically what this entire project is based on, is this image right here. But I'm going to close this tab because it's kind of interesting to discuss how this actually works. So if you wanted to customize this, really all you need to do is you need to update myport.csv to include the shares that you have in your portfolio. And I would recommend somewhere between 10 and 30 different symbols. Otherwise, you will likely have squares that are either too big or too small, and visually will not look as good, right? So if you have, like I said, 10 to 30 different symbols in your portfolio, go ahead and add them here in this myport.csv file. So next thing, we need to basically talk about whether or not we draw this red or green, right? And so if I were to kind of give you a horrible demonstration of what that is, I just open up Notepad really quick, and we'll talk about this in a moment. But basically what we're going to take is the close price minus the open price of a stock, and that is going to give us the change, right? And so if the change is negative, we will have a red square, and if it is positive, we will have a green square, right? And if it's somewhere around 0, then it will be purple. And that's basically the logic that we're going to use. So of course we need to get some information, and that is where you see this key here, which is going to be Polygon. You can see that it's basically a market data API. And the reason that I chose Polygon is not because they sponsored this video, which they did not, but because I was able to get close information and open information for a given stock symbol. And then basically it would allow me 5 API calls per minute. So I could come up with a script that would run in about a couple minutes time, 2 or 3 minutes, but it would give me all the data that I needed for the stocks in my portfolio, and then I could demonstrate them in my own heat map. So I would recommend, if you want to go ahead and customize this, to create your own API key by signing up to polygon.io and going for the free API key here, but I will leave that up to you. Now, once you do that and you get this information, you can basically create a new variable called Polygon API key, and you'll set that equal to your key here. Obviously, put that in quotes, and you need to save this in the .env file that will be up to you to create, right? So I will go ahead and paste my information in right quick. And so now back in the Go file where I actually do go and get data about this, we will reference that through the environment variables. So I have added the environment variable, and now I can simply run the script, right? Which would be, and actually I'll make a couple modifications just so you see this. So I'll get rid of NVIDIA and I will add something like, let's see, Delta, okay, which is DAL. And then who else can I add? Zora, and I can put like 87. I'll get rid of Netflix and put BA. And I'll put 17 here. Okay, so that'll be enough changes for you to notice, most likely. Netflix obviously is gone. So I can run this script, and what's going to happen is it's going to call to the Polygon API. It is going to get the open price of each of these symbols, for example, BA, and then it's going to get the closing symbol. And what it's going to do is get the difference between the close and the open, and then that will determine whether or not we're going to draw this as green, red, or that purplish neutral color. So I'll go ahead and run that, and again, it will take a few minutes. Go run get portfolio.go. So as you can see, the CSV file was written successfully, and we can go ahead and take a look at that because it is written to data.csv. You can see that this was modified. So we can see that, yeah, Netflix is gone. We now see BA and so on and so forth. So if I were to rerun this with the updated data, we can just do data. And so there we go. This is the updated version that basically had those new symbols that we added. And so you can basically see that it would be pretty simple to add your own stock symbols in there and get your own detailed heat map, which is pretty cool. So in the FinViz version, they definitely did break them down based on category, like Home Depot was in, like, I can't even remember, like consumer or something like that. MSFT, Microsoft is in technology, so on and so forth. I did not go into that much detail because I thought this looked good enough for my purposes. And of course you could screenshot this, or you could just periodically look at it to see on a day-to-day basis what your portfolio performance actually looked like. So at this point in the video, you should be able to create your own heat map using the functionality that I have just described. And I wanted to take a few minutes to actually dive into the code. So if you're interested in learning a little bit about Golang, that's basically the whole reason why I went down this path instead of using Python, which I'm obviously a lot more familiar with if you've seen any of my other videos. But I did use this as an excuse to learn some Golang, so we're going to jump into basically what you see here, and that is getportfolio.go. So this did take me quite a while, and instead of doing a live coding exercise, I figure I'd just kind of walk through basically everything that we see here, starting with the imports. So Go is really interesting because if you have an import that you don't use, it will just get rid of it when you save the file. And I think that's just something that VS Code does automatically, but I don't think it will let you import stuff that you don't end up using. So these are actually things that all get used. As you can see, I'm using the REST API client for polygon.io. I'm also using the .env, which allows me to read from our .env file to get our API key. And then I have some other things for reading CSVs. I have something for my web server, which is net HTTP, and a couple other things that aren't really that interesting. But really, I'm going to talk about these functions in a moment. We're going to jump down to our function main, and we're going to talk about basically what I'm doing here, which is looking to see if any command line arguments get passed in. And if not, we're just going to go ahead and run our script, which basically gets the data from myport.csv and writes to data.csv. So kind of the heavy lifting here is that we create a struct for each one of our symbols, right? So they're in this ticker info struct, and if you wanted to know what a struct was, you could really, obviously Google it or ChatGPT it. It is just this way to have structured data. But the big difference between a class or something that kind of resembles that in other languages would be that there are not actual functions or methods within it, right? We can kind of see some of the things that I'm interested in, right? Like I'm interested in the actual stock symbol. I want to basically have a percentage of how much the stock symbol changed on the day, the close price, the close total value, which is my portfolio value. Of course, that would be kind of the close price times the number of shares that I have. And then we also need to determine the percentage of my portfolio, right? Because we're going to use that percentage of portfolio to determine how large the actual squares are in the heat map. So really what I'm going to try and do is to load the API key from the .env file, and if there's an error, you'll notice this in Golang. Basically, you have to handle errors constantly, but if there is no error, we will connect to Polygon this way right here, and this is from the Polygon documentation, right? And so then I read information from myport.csv. And so as we read this line by line, we are going to keep track of a few things, right? We want to keep track of the total portfolio value, which is going to be a running total. Basically, every time we do an API call and we get some information on the close price, then we need to basically add that to this total port value variable here. And that does need to be a float 64 because we are going to have a decimal, right? So as we read this line by line, we are going to prepare for our API calls for each stock symbol, right? So we're going to create basically a couple of different variables each iteration, right? One of them is going to be the stock symbol here and ticker. Then we're going to have the number of shares. Our variables are going to consist of the open price, the close total, which again is the close price times the number of shares that I have in my portfolio. Then we're going to determine the percentage change, and then we're going to format that accordingly. And so then we're going to actually create a new instance of our struct, and that's going to contain all of the information here. The one thing that we cannot figure out just yet is the percentage of our portfolio, because we need to actually have the total of our portfolio's value before we give this a percentage, right? So at the end of that, we can basically iterate through all of our stock symbols, and we can come up with that percentage here. And then, of course, we can kind of round out all of the information that needs to be in each of our structs. So at this point, we can basically create a new file called data.csv, and we can write to that CSV a series of columns that we're interested in, right? We care about the stock symbol, the close price, the day change, and the portfolio weight. And so basically when that is filled out, of course, we see what we see in data.csv. You can see that those column names are written to the very first line. And then, of course, we have the information from our structs here. And this is just some formatting numbers stuff, so we make sure that everything looks uniform and neat. And we do have some error catching if we are unable to write the record to the CSV. And that's pretty much it for the main logic of the API calls to get the information for our myport.csv file. So you did notice that I did a couple of things to basically have like a local web server, and that's basically what you see right here, right? If I pass command line arguments, and it basically resembles this here, go run get portfolio data, or this could be anything. Honestly, this could be anything. If there is an argument right here and nowhere else, then our os.arg's length will be 2. And so then we're going to call our serve function, which we have not discussed just yet, but basically this is a boilerplate function to host a web server. And so I am taking a string as an input, and I am saying if it's green, then we'll load from our data green CSV, right? And this is a simulation of a green day. Conversely, this is a red day. And finally, any other argument will just end up equaling data.csv, which is the one that we actually want to read from by default anyway. And so this will actually write into our template.html file, which then gets basically displayed for our index, and that gets created here. And our template is kind of neat, right? Because it lets us determine which argument we're going to load. Finally, I wanted to discuss the JavaScript, of which I wrote very little. I used ChatGPT to figure out, basically for the prompt, how can I display rectangles based on a percentage size, right? And then I kind of went from there, and I went to basically an RGB range that starts with red, is kind of this neutral purple color, and finally is green, right? And that gives us kind of this d3.scale linear, but really d3.js is what does the majority of the heavy lifting for the heat map itself. So if you're interested in that, of course, you can just go to d3js.org. This is a really nice data visualization JavaScript library. So in closing, this is kind of what the heat map looks like on a mixed day. We saw examples of green and red days as well. I just wanted to thank you for watching, and I'll see you in the next one.